So today, Saturday, and the last set we did was that President whatever it was, and this is the same customer. This is a Binatone LongRanger 40, and it clearly has some issues. See what's in the battery compartment. I think we'll change that clip because it doesn't need to be taped together really. That's seen better days. I think we'll offer him a replacement, to be honest, only about £3.50. So we'll open it up. That's if it gets that far. Of course it may not be repairable. Now these are one of the best ranged hand portables they are, and part of this is the metal case because you're going to act as part of the ground plane. Now the big realistic 1001, 1005 and the 2-channel but still hefty 1.5 watt 1002 for the UK market all do really good range, and that's down to metal case. In the case of those plastic realistics, they have the range boost side panels, which isn't bull. It isn't marketing bull, it's real, it's true. So what's happened here? Well, it's come away from the printed circuit. How come? Don't know. The board's going to have to come out because we don't know what's underneath causing issues. So it looks like it's on channel 20. I expect this is something he's bought off eBay. Yes, that's the way to do it. So I think what we'll do, we'll take this. I think somebody's trying to dismantle it and you don't take those 2 screws out like you don't take those 2 screws out, and they have done. So what we'll do is we'll take the aerial off at the proper point, which is there, and then we can secure, just make sure we know which way this is. It's the down, yes, got it. I think we need to just pull the microphone insert out like that, and then it does unfold like a book. So we just need to make sure that these screws are tight in case they've been meddled with. And now we can fit that bracket back. it. And the lower one. We've got Mark here this weekend. He's poked his head round the door. Hello, Mark.
Hello.
So we're doing a Binatone LongRanger 40,
Ooh.
which I'm sure is a better set than that President we did last. Don't know what screws go in this.
They're good handhelds, those.
Yes, about the best range there is other than the realistics. See some screw that fits. So this is what happens. Somebody takes the wrong bracket out and it actually generates quite a bit of work. So we can get that back. We can actually power the thing up and see what's working and what isn't. So there we are. That's back together. So we'll power it up from the accessory socket, which is here, and it says you require 450 milliamps for your mains adapter, which seems quite low considering it's a 4-watt radio. It also tells us it's positive inner. Okay, so I've come to the conclusion, not that I can find a circuit, I don't even know if we've got one, I thought we did, but it's the PTT switch. The set's been put together wrongly and it's been forced together and it's bent the PTT switch. So let's turn the volume down a bit. So that needs to come out. There we go, we've got transmit and back to receive. So nearly, that's just overshot it. There we go. So we will put some spray on that, wherever my service all is. So we've got receive. And we've got transmit. So it's doing 2.5 watts. You're still not happy about that. It's not always returning to receive. Now these look to me to be one of these sets with a triple crystal arrangement. So we need to set the 10.24, whichever that one is. Now the 10.24 here isn't adjustable. So there's no trimmer there at all. Clearly the VCO is in lock, we're not going to have to mess with that. So one of these trimmers will be for transmit and one will be for receive. So let's go into transmit and we'll turn the one furthest away. This is today's guess. Let's put the camera on frequency counter. It's 2779-100. It's in spec still, but let's just see if we can pop it up. So I'm going to do the one furthest away from me. No, that's not the one. That must be receive. That's transmit. So normally we'd set the 10.24. We can't, it doesn't adjust. And then we move on to the transmit one, which was the one nearest to me. So of course now we'll have to set the receive frequency with a secondary signal generator. So let's make sure we have 2779125. We have. I'll just trim that exactly. Okay. So now we'll set up the secondary signal generator, which is the cheap Chinese one at 10.695. We're using this as a marker oscillator. You can use 455 kilohertz if that's all you've got available. We'll take the tone off, just turn the volume up, take the tone off. So we've just got a blank carrier. May as well take the picture-in-picture off. Switch this on. And this is set to 10.695. And we're going to want it on channel 1. There we go, channel 1. And what we need is a BNC adapter. Into channel 1. Now can you hear that musical note? That's because the receives off frequency. So we now know it's just loosely coupled. I'm just dangling the wire somewhere near the IF. Put the trimmer on there and we need to null, therefore netting it onto frequency. So be clear, 2779125 channel 20 on the signal generator, 10.695 on my second signal generator. So the only thing that can be out is this. Now that was miles out. Now you know I adjusted that in to try and find which was transmit. But it wasn't like I had any movement like that. So that's fixed that problem. So it will now receive properly, which it probably hasn't done for a very long time. So just go through this and see whether we can tune it any better. There's a crystal filter in here on receive, which is quite impressive for a hand portable. Well, they work very well anyway. Okay, so we'll go back to the power meter on the test set and switch picture-in-picture back on. So here the transmitter is clearly here, so without the manual we've got to wade our way through this. Why is that on such an angle? So something's really pushed that over, and the two pins that connect it are at this end, and the two pins that don't connect it are at this end. So I can't just push that back on its pins. So I'm going to actually have to unsolder that. So we'll switch off the power, unsolder that connect that component, and make a proper job of it, because it does look a bodge and a mess. Can't see any reason it's not coming out. So we'll bend it the right way. So that's one of the pins. Push that back in. So I think we've lost the other pin. It's probably got sucked into the solder sucker. It might be that I can put some solid wire. Now Mr. Chippie nicked my reel of solder off here, but I did pull a bit off the reel before that happened. That's got a bit of a gangster lean as well. Right, we'll power back up, go into transmit, and let's go through it. So, just need to melt the wax in there. It's in the right position. That core is in fact broken. So if I'll turn the power off again. If we can just get that out, we should be able to turn it round the other way. This really has had the golden screwdriver at it. So, like I predicted, the other end is okay. So we'll put it back in. Power it back up. Going to transmit. Something's dodgy here. That's it. So that's a good 2.5 watts there. And I think that's going to be the final one. Yes. So it's just about doing 3 watts. I'm sure if we turn the power supply up beyond the 12.8 volt it's at, that we will get more, but I don't want to thrash it. And there's little to be gained apart from increased power consumption by taking it much further. These bits of fluff look like blown capacitor, to be honest, but I can't see a capacitor that's blown its load. So whether or not that's a previous repair that's been and gone. Right, so let's look at where the deviation is. Wallow, want it. Set the meter. 1 2 1 2 wallow. 1 2 wallow. 1 2. Just doing under 2. See whether we can bring that up. Deviation is on this subboard underneath, so we've got to try and do the shuffle here. So we'll put that kind of there. One, two. One, two. Wallow. 1 2 wallow. 1 2 wallow. That's about where we want it. Not easy to set. But that's your deviation. The speech processor is around that chip and that circuit there. So that's our transmit done. So let's look at receive. Well, that's 1 microvolt. So let's put the cyanide meter on. Tell you what, before we do that, we'll do the detector. Do you know, I doubt there's anything up at all with the receive. It's just off frequency, as I showed you. So we'll go over to the side of the oscilloscope, switch the bench light off. Hope it's got an earphone jack. It has. S9 equivalent and turn the volume down to get a sensible trace. Rather than faff with the oscilloscope, I'd rather faff with the volume control. We need to define the detector coil. Clearly to me the detector coil is going to be this one here. So let's just make sure that's absolute peak. Yeah, there's hardly anything in it. Now we'll go over to that synod meter. And at the moment, it's actually doing 0.68 microvolts for 12 decibel synod. So, considering it's a hand portable, it's already very good. I probably won't get any improvement at all. But nevertheless, we'll run through it. So we now to attenuate the signal so we get about 4 dB. So my adjustments are meaningful. And I'll just guess that we're going to be doing L2, L3, L4, L5 will be an IF. So here goes. L2. Well, to be honest, I've just gained a bit. L3. L4. Let's turn the signal up for the L5. That's going to want a bit more signal. There we are. There's nothing further I can see. Let's get a new reading. So for 12 decibel synod, it's now 0.55 of a microvolt. So we've brought it down from 0.68. So we've gained a little bit, even though it wasn't faulty. So that's it. We know it's on frequency now. We did that. We can check the squelch. There's no adjustment for that, but we can check it. So turn the squelch to full. There we go. Let's see where it is. Well, it's pretty wishy-washy. It comes in at 1 microvolt, but it's a hand portable, so it won't be overly critical. I can't see any preset on the board. It's got low power. Let's just see out of interest. We'll go back to transmit. And out of interest, we'll see what low power does. It should be 0.4 of a watt. And it's 0.1 of a watt. So there you go. So a few hours later, I've had Mr. Chippie look at the switch on that radio because it was a bit very much dodgy. Whilst it was in bits, I've been across to our organ workshop and using the engineer vice, I've managed to straighten it up. Now I found another of these, which is one of our sets. What I'm going to do, because Mr. Chippie's put it back together and now the radio doesn't work. So whether or not the switch he has attempted to repair has got worse, or whether there's a wire gone on in the wrong place because it was a bit ambiguous, we'll find out by simply going inside our own set. So here's our Binatone Ranger 40. This is one which is totally untested. Looks very corroded at the bottom, but those battery packs are readily available. What isn't on that customer set is that grommet. So I think we're just going to have to wrap some tape around if we actually get it to work and we're able to give it him back. So you can see what a state this is in from battery corrosion. So we'll unscrew ours. But our switch is in beautiful condition. Where do we start? Couldn't see the screw because it was so corroded. sure why this won't come out. Oh, I'm not taking the knobs off, am I? To be honest, ours doesn't look that bad inside. So, let's have a look around this switch. And we'll get the customer's one here. Right, well, amazingly ours is different inside. So the orange wire on his goes to the second pin. The orange wire on this goes to the first pin. So there you are. We've got a brown wire we've got a screened cable on this one, which goes from 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 to the point over there. So that's correct. So it could be simply that that one's in the wrong place. They can be a bit ambiguous where they go. If it's bridging several, you know. So you think you're putting it in the right place and you're not. I think we're going to have to take that out of the clip to gain another. No, we don't, because we can take it to that point there. There we go. So 1, 2, 3, 4, 5, 6. Yes, the screen wire is the difference. They've improved it on this one. Right, we'll power it back up. Interesting. Oh yeah, it's not plugged in, is it? I was going to say that's a bit 10-1. There we are. Wallow. 1, 2, 1, 2, wallow. Lovely. Right, we'll put it back together and see whether it still works when we put it back together. There we go. Wallow. 1, 2. Excellent. Right, we'll put it on the aerial. turn the test set off. I'd hate to have to take it apart and put it back together again. Will anybody be on at 8 o'clock on a Saturday evening? Well, no, Roger. As ever, somebody's just having a conversation. They don't do 1.9 for sudden. They don't change channel. They just sit there on 19 talking. That's why it makes it unusable. Right. Well, we do about. We don't even really do CB radios. Our business is in business radios, and we do about. We must be doing 250 CB radios a year. They're going somewhere, aren't they? Imagine this bloke's got about 40. So that's it. That's the Binatone LongRanger 40. So we were able to replace the insides of the broken PTT, which was broken through it being messed about with. We were able to replace the insides by taking the switch out of a cheapo power mic, which we only put in the bin anyway. We cut the leads off if they're any good, and we throw the mics away. And so we're able to use a 4-pole changeover switch, and Mr. Chippie took it all apart and put the replacement innards from that scrap power mic into the radio, and then put the shaft in, which I'd straightened up, and the job's a good one, as they say. I'll ask the customer about the battery case, but we'll do an on-the-air test from here on the aerial tomorrow, and I'll see whether Mr. Chippie wants to do a field test or whether he wants me to sort ours out, and we'll do it on that one. So there we are. Thank you for watching the Binatone LongRanger 40, a very worthwhile handheld from 1981.